know you had a couple other choices, so it feels good to have people choose my room. Yeah, so here's my About Me slide. My name is Andrew Kelley. Yeah, I created the Zig programming language. I'm the president of the Zig Software Foundation, which is a nonprofit. I have 22 years of programming experience. I don't know how old I look, but I've been doing it a while. And I love open source software. I've always loved it. I like the community aspect of it. I like the idea of giving back to the world. And that's kind of where my mindset's at. So let's take a nostalgia trip. Does anyone remember GeoCities? Anybody? Yeah, all right. I see like 60% of the room maybe. So I had to find this in the Wayback Machine. It's missing like the background, you know, but I made this when I was a very young person. I love this, like this bug reporting. Like click the option button for the software and then, yeah. Well, anyway, when I discovered that I could instead pay $5 a month and upgrade to Host Monster, it's like, whoa, mind blown, right? Now you can SSH in and you can run some PHP stuff. Wait, I don't want to use PHP. I want to use like Perl or Python or something. So if you figured it out, you actually could install whatever programming language you wanted on these systems. Did anybody figure out how to install software on the shared $5 a month like hosting sites? Okay, well, you're in the right room then. If you go back in time after this talk, you'll be able to do it. But anyway, that's just for background. That's kind of where my fascination with installing software from source comes from, because as a kid, I was able to gain access to the software that otherwise I wouldn't be able to have. So here's what we'll talk about today. Little smorgasbord of topics. Hopefully, you'll come away with it with a new skill. Wait, hold on though. Wait, isn't caching in there twice? Oh, hold on. Okay, I guess get rid of that one. Oh wait, I feel like one of them is missing though. Hold on. I think I need to install something on my terminal. Okay. Yes, dependencies. Okay. Yeah, so those are all the topics we'll get into today. So to start, all right, come on, fess up. Who's done this? Huh? Let's see, one, two, a few people. You can learn a lot about someone by how they obtain their software. You can also learn a lot about someone based on the fact that they judge people based on how they install their software. But okay, so what are actually the problems with this little snippet, curl to sudo shell script? People say it's bad, right? But why? The answer that you'll get is that it's because you shouldn't trust the person on the other end. Like, well, what if you download something bad and then you're running it on your computer? That's actually the wrong reason. Like, you're about to run their software anyway. Of course you trust them. So why is it actually a problem? Well, it's the problem for two reasons. One, you don't need to install it to root, so you don't need sudo. And two, the script is probably just putting it somewhere messy. It's just making a mess. That's the actual problem with this. So really what this little image is depicting is just a way to obtain software, which is an upstream binary distribution. So upstream means it's the people who make the software. That's upstream. Downstream would be someone who takes someone else's software and packages it and does something with it. So if you install software this way, you're actually getting a specific kind of experience. You're getting the intended experience according to the people who make the software. And maybe that's the right way for you to experience that software. You know, if your main focus is getting the experience that the developers of the software want you to get, that's a good way to get it. But it might not take into account your system's unique setup. So maybe on your system, things work a certain way, and the people who make the software didn't think about that. And software doesn't actually work very well on your system. So for example, maybe I use NixOS, and I download a binary from upstream. It doesn't even work because the dynamic linker is the wrong path. Or maybe they don't take advantage of the, like they didn't use glibc, so they didn't get the DNS resolution code from glibc that you rely on at your company, something like this. But, you know, weird things like these can go wrong if you get the software directly from upstream. So another way to get it software would be from a system package manager. So if you use Linux, this would be like your apt or your yum or what have you. If you're using Mac OS, this would be Homebrew. If you're using Windows, they have a few like chocolatey and some other ones like that. I haven't used those before. But in this case, you're getting the intended experience according to the system maintainer. So the system maintainer goes and finds a bunch of software, figures out how to run them on your computer in the best way that they can interact together, and then that's how you're getting that. So this is easy. Apt-get install, that's easy. It's pre-configured. Someone else already chose the configuration options for you, and it integrates with your system. So those are the upsides of doing it this way. But it's pre-configured. Maybe they chose configuration options that you wouldn't have chosen. Maybe they chose configuration options that the person who made the software doesn't want them to choose. I've seen this conflict happen between the Node.js upstream developers and the Debian package maintainers, for example. And finally, we have obtaining software directly from source, which is the focus of this talk. So with this one, you can install any version you want. You can edit the code and then see your changes immediately. You can contribute back to the software if it's open source. That's something you can't do with those other two ways of getting the software. And you can configure it exactly how you like it. So, of these three options, I think that there's a time and a place for each of them. And I don't think any of them is better. I don't think using something direct from source is necessarily better. I just think it's underappreciated. And so I want to help it become more appreciated, and then you'll have the proper choice between the three. So that's what we're going to talk about today. So we just went over ways to obtain software. So let's go next into how about some core concepts, because this is a bit educational. I will throw in like a little thing at the end where I'm showing off something I made, but the first part of this talk is actually just educational. So let's go into some of these core concepts about installing something from source. So you just downloaded something. In this case, well, the font's nice and big. That's great. In this case, we downloaded FFmpeg. Has anyone heard of FFmpeg? Yeah. Audio, video software, open source, has like a whole bunch of formats. It can understand like any audio, any video format. Open source. Let's try to build it. So the first thing that happens when you unpack it is you have to do the configure phase. And I think that a lot of people struggle with building software from source because they don't respect the configure phase enough. They don't treat it with enough dignity. They don't understand that that's like the most important part of the whole building software from source thing, and they kind of gloss over it. They don't really read it, and then something goes wrong, and they don't realize it was because something went wrong in the configure phase. So let's look at some of this stuff. Mike's okay, yeah, with them mocking? Okay. So I just ran configure help. And a lot of times the help menu, it's actually pretty helpful. I would recommend to read the help menu of the configure script because it will tell you what's possible. So in particular, this prefix, we're going to come back to this. That's really important. But also we can see for FFmpeg, it's going to tell us a lot about what's available in the software. And I'm going to scroll down a little bit here. So you can see that we have some choices. We can first of all, we could just only install some programs. We could not build the documentation. Okay, now we're not quite to the interesting options yet. Let's go down a little bit more. Okay, now we're starting to get somewhere kind of interesting. So you're actually, this list is like very long. I only included a couple screenshots, but you're actually fully deciding like which ones do I want to support. So maybe I want to build like a really lean FFmpeg build. Maybe I'm going to compile it to WebAssembly and I'm doing a cool little demo, and it's important that I don't make you download too much stuff. I actually only want to support MP3 and Opus or something like that. This is where you can decide that. You're not going to be able to get a build of FFmpeg from a third-party vendor that only has exactly the three things in it that you want that's minimal for your exact use case, something like that. That's something you could do if you build FFmpeg from source. So scrolling down some more, at the end of running the configure script, sorry, yeah, at the end of running the configure script, it's going to tell you like, okay, this is what we were able to enable. And if that list looks good, then you can continue. But if that list looks bad, then you should stop now. Like you already are not compiling the software correctly. And I think one of the biggest things that people run into is that they don't realize that they've already failed. You know what I mean? Like, you got to know when it's not working and then stop. Like, that's the part where you work on it. You don't go try to build it and then run into some weird error later. It's like, no, it didn't work because I ran configure and it didn't say that it was going to enable MP3 and I wanted MP3. That's my point here. So there's a little pop quiz to see if you're paying attention. Should we ignore this warning? Who thinks we should ignore this warning? Okay, nobody thinks we should ignore it. That's good. That's good. This is a successful talk so far. So if I were trying to configure FFmpeg right now, I would go back. I would install this dependency. That's what this is. This is a dependency. And then run configure again and make sure the warning goes away. And if you ignore a warning, you're gonna run into trouble because someone put that warning in there because when they test this on their computer, they don't get that warning. So if you're doing this, you're being like Robert Frost. You know Robert Frost, the poem guy, walking the road that is less trodden? That's not good for software. You know, if you see two woods diverge into software woods, you take the path where everybody goes down it. That way, it will work. So this is where the two roads diverge, and you don't want to take the path less traveled. Okay, so let's look at this. Let's look at this prefix again. So this is really, really important. This is the most important concept of installing software from source. And if there's one takeaway from this talk, it's just you got to pay attention to the prefix. So do you see the default there? User local. Okay, why do we want to put software in our root directory? Is that where? This default is insane. I don't know why anyone thinks that this is an okay idea. So the prefix is where the software will get installed to. For example, if you have a bin folder or a lib folder or include folder, all of these are relative to the prefix. So it's like prefix/bin, prefix/lib. That's pretty much it. Just bin is where the binaries go, lib is where libraries go, include is for C and C++ headers. So if you put it in user local, you're going to have to use sudo in order to install the software. But that's unnecessary. You could just put it in your home folder, and it works fine. Why would you do that? Why would you use sudo for that then? Also, if you put it in user local, then other software might look there and depend on it when you didn't expect it to, when you didn't authorize it to. So yeah, installing things globally, it's unnecessary and it invites untamable chaos into your computer. And you don't need that. You can just give it a prefix that's in your home folder, like home/my prefix, home/local, whatever you want to call it. Also, it's not really possible to uninstall from a prefix. It's not really a concept that exists. It's like once you put stuff in the directory, you can't really take stuff out of it in a sensible way. So the only way to be able to uninstall stuff is actually just to have a bunch of prefixes where it's like, okay, this is the one where I install these things to it, this is the one where I install these things to it, and then you just delete the entire directory. That's the only way you can actually uninstall stuff. So my point is, just pick a prefix in your home directory. Don't use the default. The default's bad, and then everything will go like smooth sailing from then. That's my main suggestion. Okay, what about Windows though? So Windows doesn't really have like bin and lib and stuff, right? Like if you're making a zip file for Windows, what should the directory structure be? Well, you basically have two choices. So you have to pick one. You're either going to make your application consistent across all the operating systems you support, which is like the approach that used by people who use what's that browser engine that everyone uses for UI? Like Signal uses it. I forget what it's called. Yeah, Electron. So the left one is like the Electron approach, right? You're like, well, I don't really care what's normal for Windows users. I'm just going to make my application be the same everywhere. That's fine. That's a choice. And then the right button is like, okay, well, I want Windows users to have the same experience on Windows with everything they use. So you're like trying to cater to the audience. So I don't know. That's kind of the choice you have with your install prefix. Well, okay. So who would pick the left one? Which one? If you're building your software, not really anybody. Okay. Who would pick the right one? A couple people. Okay. People who are, I see people who want to investigate more before making a decision, and that's respectable. Okay. Yeah. But I also like the confidence of the people who answered. All right, so let's go one more core concept here. So that was the configure phase. So if you look at the configure output and everything's good, like, okay, now we're ready to proceed to the build phase. So now we can just run make, right? Well, unfortunately, make has terrible defaults. All of this software has terrible defaults. You actually have to opt in to your CPU to using your hardware. Like if you don't opt in, then make will run single-threaded. Like all of this CPU hardware in your computer will just sit unused. All that money you spent on your computer doesn't matter. Make doesn't care unless you opt in. Okay, cool. So now we do this, right? No, because if you just opt in, the default is to fork bomb your computer. It won't just use only how many cores you have. It will just do it as much as possible until you run out of memory and your system crashes. Okay, so don't do that either. You have to give it a number. It's ridiculous. So like on this computer, I would have to say 16, for example. Or you can run a little command to figure out how many cores you have. It's super annoying. But you got to do it, otherwise it's slow. All right. So that's the build phase. So once that, assuming you don't run into any errors at that point, we're ready to go to the install phase. Right? Is this what we do? It's a trick question. So no, you don't need sudo. Don't do it. There's no reason to get root privileges involved. The only reason you're ever told to use sudo make install is because the default prefix is in like user local. But you could just not do that, and then you don't need sudo. In fact, if you don't use a root prefix, if you just make a prefix in your home directory, you don't even need to separate the build and install step, because the install step depends on the build step. You don't even need to separate them. You just do make install. It works fine. So you can skip those two things if you use a good prefix. This is like, I'll die on this hill and nobody else cares. I don't know why, but I'm trying to bring more converts to this way of doing things. But it really saves me trouble. I think it will save you trouble if you try these things out. Okay, so you have like some of the ideas about how this stuff goes on. So now let's go on to this to don't list. You know like a to-do list, but it's like don't do it. So in other words, insane things I've seen people do while failing to build from source. No shame if this is you. I've done all these things too. So we've all been there. But yeah, when you're building something from source, make sure you use a release that makes sense, like 0.10.1, or use like the release version and not just some arbitrary commit from some branch or from the development branch or something like that. Because people just push broken code all the time. You got to pick the release that is going to work. Again, we're not trying to be Robert Frost here. We're trying to pick the road most traveled. Using a different compiler than your system toolchain, this is an unfortunate pitfall that mostly exists because of C++ where things are going to break, with exceptions. And if you know what these exceptions are, you can do it. But if you don't know what these exceptions are, this is a pitfall. So start with this. Get it working like this. And only then, if you want to move on to using a different compiler than your system toolchain, learn about it, do this advanced thing. But start with just the system toolchain. Oh yeah, this one's always funny. Using Docker or virtual machine. You actually just almost never need Docker, just in the world. Like, Docker exists because people don't know how to build things from source. There's use cases for it, for sure. But you don't need it, and it's faster not to use it. It's a layer of abstraction that you could just get away from. And again, it's advanced. You could use Docker, there's cases for it, but using it as a crutch because you can't build it for something from source, you're probably using it for the wrong reason. Oh yeah, this one's fun. So I've seen people run into trouble and then they just go in and they kind of do the build process somewhere and then somewhere else. They just move like header files around and not. Don't be doing that. Just do the normal process. If the normal process doesn't work, get help. Don't do weird stuff. Because if you do weird stuff and then you report a bug and then you tell the person I did all this weird stuff, the person's going to say, I'm not going to help you with that. You're doing weird stuff. Do the normal stuff and tell me what went wrong doing the normal stuff, and I will help you with the normal stuff. So this is the same issue, basically. Like, when you do your configure scripts, start with a basic build, play with it a little bit, but just kind of know when you're straying from the main path, and then finally just start editing the code randomly. I've seen this one too. So the thing to remember is that when you're trying to build something from source, someone did already do it successfully. It worked for somebody. So if it's not working for you, figure out why. Advanced is you can do it. There's a good reason to do it sometimes, but you should know what you're doing. If you're a beginner, you should avoid these pitfalls. Learn the basics before you do the advanced stuff. That's my point here. Okay, so that's my to don't list. So now we're going to move on to some troubleshooting tips. So I can give you some actually helpful advice instead of just what not to do. But this topic depends on dependencies. So we're going to do that one first. So dependencies is kind of the #1 reason that people don't build things from source, I think. So for example, for a lot of software, if you don't have the dependencies installed, you just won't be able to build from source. So you will get errors, which is expected. So then you kind of have the choice. You could just go build the dependencies from source. That works fine. So if you want to do that, that works fine. You just go build the dependencies from source, you pick this prefix, and then you go back to this one, and you pick the same prefix. And you're kind of throwing everything into that directory. And that becomes your directory that has all of that stuff, including your dependencies. That works really well, actually. And if you want to personally hand configure everything in your whole software chain, you can do that. Or maybe you don't want to be bothered, and you can just use a system-provided dependency. That's fine. But just keep in mind that the system maintainer is the one who chose those options. So maybe I'm making a music player, and I want to depend on FFmpeg. But if I get FFmpeg from my system, actually, they had some licensing issue where they thought that MP3 would be a problem, so they just didn't have MP3 enabled in the system FFmpeg, but I want to be able to play MP3s in my music player. Then I can't use that FFmpeg as a dependency. But if I build it myself, I can enable that option, and then my music player will support MP3. These are kind of the trade-offs you have to think about with dependencies. Yeah, that's it for now. OK, so moving on to the troubleshooting tips. Typically, a software project will document what versions of dependencies that it needs. Just make sure you connect these correctly. If it says it needs 0.10.1, make sure that's the one that you get. Or you can pick the next bug fix release, but not the next minor version. So use compatible versions of software. Use actual releases and not arbitrary commits in the source tree. You can go up in the bug fix releases. That's probably a good idea, actually. And then when you make bug reports, try to make a bug report on following the directions basically. If you can get the bug to happen without doing something complicated, that's going to get responded to much faster. And always include actual error output from everything. It can be very frustrating for a maintainer to see just the words "it doesn't work" followed by nothing else. Yeah. So almost every failure to build from source will be one of these issues. That was just the wrong version of the dependency. The system maintainer just did some weird configuration options that the upstream developer didn't expect. Missing dependencies. You can usually see the missing dependencies from the configure output. So make sure to scrutinize that. Or this one's kind of common. It's just they didn't test that version of the operating system with that version of the compiler. And there's just some little error. And that can usually be fixed with a tiny little patch to the build script. And those kind of patches are actually appreciated by the maintainers. All right, what's next? How about caching? This topic is frustrating because everyone's used to make for building software. An alternate title of the slide could be like, why make sucks. But so make uses this thing called mtime-based caching, where it checks if, like, okay, so last time I built the file, it had this timestamp, like, date, time, hour, second. Like, all right, now I'm running make again. Now I see that the timestamp is like 10 seconds later, so it must be new, right? Cool. But like that just doesn't work at all because time systems go backwards, there's daylight savings times, file systems just don't do it right. It's like, you just can't do that. But they still do that. So it's just broken sometimes. Sometimes you just run make and it just gives you the wrong results. It can be fixed if you just note the m time, and then like if the m time is ever different, and that's a different file. But that can still go wrong. So like some file systems actually, they just have like really poor granularity, like 10 seconds granularity or more, or even 1 second granularity means that if you build your software, make a quick edit, build your software again within 1 second, it's not going to pick up those changes. And if you're doing that in a script, that's actually pretty easy to trigger. Your script just says like make, edit the file, make, broken. It doesn't make. So you can fix this with paying attention to other things too, like the inode of the file, the size of it, the hash of it. But you're still going to have, you don't want to have to hash the file every time. And you're still going to have m time as granularity as an issue. So it's just like a very difficult problem to solve. And if you think of it later, check out this link I put in here because that blog post is like very eye-opening. It's pretty fun. If this is interesting to you at all, then I think you'll like that blog post. Another problem with using make is that these dep files, which is how you get dependencies out of C and C++ compilers, they're just kind of tedious to do correctly in make. So a lot of projects just get them wrong. So then when if you edit like a header file and you run make, it doesn't know that all the C files that use that header file should change. And then you try to debug something and it makes no sense. It's very frustrating. So anyway, point being, a lot of build systems get caching wrong. And it can be a huge time sink when a process that you've been trying to iterate on all of a sudden doesn't work because your caching abstractions broke. Let's move on from that, but I'm kind of leaving this one as a cliffhanger because I'm going to show you how I address this problem. All right, so caching's done. Let's go into build systems. So I was talking about make just now, and that's kind of a classic one. So a lot of older software projects, they're going to use auto tools and make, which is where they use a configure script that generates make files. Then you run make to actually do the stuff. There's an alternative to make that kind of sits on the same abstraction layer, which is Ninja. So that one just has better defaults. Like if you run Ninja, it actually uses your CPU cores directly instead of not doing that, which is nice. But it's still the same abstraction level. So Ninja has to be generated by something else. For example, like CMake. Has anyone used CMake? Okay, yeah. Yeah, so if you use CMake, you can use Ninja. That's a little bit better. CMake does things a little better than auto tools, but it's still kind of the same abstraction layer where it's going to run a whole bunch of test scripts during the configure phase to test, oh, does your C compiler know how to import time.h? Which all of them do, so it's just wasting your time. But anyway, the key feature of build systems is being easily or perhaps already installed everywhere. I mean, we would all rather not use make, but we use it because everyone has make installed. That's kind of where we're at, you know? The bar is pretty low. So I want to tell you actually about a new build system that I've been working on. It's called the Zig Build System. And as far as portability goes, you can install it pretty easily. You're not going to find it pre-installed anywhere. But if you want to go grab the binary distribution provided by Upstream, it's just a 50 megabyte tarball. Runs on any OS. And you can have multiple versions sitting side by side, no problem. It's pretty easy to get. And when you get it, you get something that actually can compile all your C and C++ code that you already have, or your Zig code, of course, without depending on your system. So like if you On Windows, it works without having MSVC installed. So if you want to just grab a 50 megabyte zip file instead of waiting 2 days for MSVC to install, that's an option. It works on the macOS without Xcode. I know no one has a macOS without Xcode installed, but I just feel like it's nice to keep them on their toes. Got to have a competitor. Yeah, some people and like why can this thing compile C and C++ code? Well, it has like Clang embedded inside of it, so it's the same engine as Clang. But yeah, some people think like, oh, it's just Clang, but like there's a lot that goes into it. But that's a whole separate talk. So I saw what five or six people have written some CMake code, right? Yeah. It's nice to use like an actual language. I don't know if you've seen Zig before, but I think people who've used CMake can probably already appreciate how this looks like a real programming language instead of CMake. I am so frustrated with CMake language just being fraught with, it's like, you step here on a rake and then you're like, oh, that was bad. And then you step here on a rake, oh, that was bad. So having an actual programming language for your build scripts, it's pretty nice. It also cross-compiles to Windows, macOS, and Linux. So I give you, 2 examples here. So in this one, I'm actually running a test target, a test step. I'm just saying, hey, run this for ARM64 Linux, even though I'm running it on an x64 Linux computer. And I'm saying, use QEMU. I have QEMU installed. Use that for running the tests, and give me a build summary. And so it's like, okay, no problem. So it actually compiled my unit tests for a different architecture and ran them in QEMU with that command. That's pretty fun. And this is like a little side project, arcade game I'm working on. Again, I'm using Linux here. And I just said, please build this for Windows. And like, all right, there we go. Got a Windows build. I can ship that to someone who can test it for me. So like, you get all that with that 50 megabyte tarball that I was showing you. You don't have to install anything separate or anything like that. Yeah, I could even like run that in Wine, would work. So with this build system, it also does parallelism and caching correctly. So like in that example build script I showed you, it doesn't actually do the building in that script. The script just declaratively constructs a build graph, and the build runner will run it. So you're going to get that parallelism for free. So I'll give you a little example here. So again, with FFmpeg, I went ahead and forked it. I forked FFmpeg, and I as an experiment, I just ripped out the build system in the Zig Build System. Let's see how it works. Let's give it a little test drive. It took a bit of work because it's a big project, so I had to port a lot of the build logic over, but it worked. So I ran a little test. I had to do these numbers this morning. So if I run configure on this computer and then make, it took about a minute 45 total for using the upstream build system, which is like a shell script for configure and then make. And I gave it the correct number for the J. It didn't crash my computer. With the Zig Build System, I run Zig Build, and actually completed faster than even just the make step, despite the fact that it had to fetch the dependencies, because those are also using the Zig Build System. In this case, they were already downloaded, but it still had to check. Building the build script itself and building the dependencies. So it actually built NASM, libmp3lame, zlib, all that stuff from source on the right-hand side, and then gave those to FFmpeg. So point being that it's like using your computer's resources efficiently, not wasting your time. And that's because I solved all these hard problems with the cache system. So I won't make you read this tiny font down here, but there's a system where it computes this hash based on your inputs. That's what that first little text file is. And then inside this file, it lists all of the files that you end up depending on during the compilation. And it puts the hash in there too. So if nothing changes, then it knows it doesn't have to recompute the hashes. And if one of the files change, it only computes that hash. Then it hashes the hashes, and then that way it can know if something is fresh or stale. There's still that one problem with m-time granularity, where some file systems just have a low granularity, and you don't know if they do. So I put in a little trick where it actually just touches a file in the cache, and then it reads the M time from the file, and it checks how many zeros are at the end of it from the last time. Like, does 2 reads, and then it checks the granularity. So it just knows like how it's able to sample the granularity from the file system, and then what it does is if you're doing a build where the change to that file happened within that time of that problematic granularity, it just writes like a pre-cache miss into the cache system. So basically, it just like pre-invalidates the cache system so that it doesn't ever give you any false positives. So yeah, it took me a while to solve this problem, but it works really well. I got it in there. Yeah. It also uses this text file as a lock, like an advisory lock, so that if you do multiple processes at the same time, they actually like collaborate with each other instead of clobbering each other. Yeah. Anyway, so after you run that command with my ffmpeg fork, you get this nice little build summary. I put some little care into this. I thought it looked pretty. So each of these little lines, they actually have like the number of how much time it took to run, the peak memory usage that it has. It's not colorblind friendly yet. Sorry about that. We'll address that. But yeah, build summary. And so, oh yeah, so if you look over here, you can see that like our goal was to install ffmpeg, which it finally did. But first it had to build zlib and vorbis, og. So like, where did it get those from? Those are dependencies. Those are not part of ffmpeg. Well, this build system also is a package manager. So you can have this little manifest file where you just declare dependencies of your project. And so point being here, we're just listing some URLs, some hashes, and there's no central repository for this. It's actually just downloading them directly from GitHub in this case with a hash to make sure it doesn't change. And then once you have these declarative things, inside your build script, you can just access them. And this is just a regular programming language. This is the Zig programming language. So if I wanted to, I could even put this inside of an if statement. I could do like, well, if they requested og support, then I go grab it. Otherwise, I don't. Like normal control flow works in there. So I did that. It all works, and it built pretty fast. Compared to the actual ffmpeg upstream one. But like, so what? Like, good job. Like, what's the point? Well, I am working on a music player. This is called Groove Basin. I've had this for a while. It's in Node.js right now, but I want to reboot it in Zig. And here's the so what. The so what is that this is my README for this project. It's in a branch, but the README doesn't have to have a whole essay telling you how to go find ffmpeg, which version to check out, which configuration options to set, which like, oh, but if you're on Ubuntu, you can't use the system one because they just hailed an MP3, like blah, 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 blah. All I had to do was just say, run Zig Build, and you're off to the races. You can contribute to this project with me. You can run it. Like, for me, this is the holy grail of an open source project's README. It's like the building from source instructions are one line. To me, that's my holy grail. So that's the so what for me. Yeah, and so that's a little intro into the Zig Build System. Yeah, I wish I had time to walk you through creating a build script, but we're pretty close to the end here. So yeah, you can check this out in the next release of Zig, which is coming out in less than a month. And let's see, what else I got here? So that was this case studies, that was ffmpeg. So let's recap. This is like the summary here. So yeah, what's the best way to obtain software? Maybe getting it from your system is the best way. Maybe getting it directly from upstream is the best way. Okay, but if you want to install from source, it's actually pretty easy. Just pay attention to the configure step, particularly, and manage your install prefixes carefully. And please, for the love of God, don't use root when you install software. You just don't need to, And Zig Build System is pretty cool. Give it a try. And obligatory thing here, call for donations. So I represent Zig Software Foundation. We are a nonprofit, 501c3. Consider using your company-sponsored donation matching to keep us funded. So a lot of people's companies, like you can actually just pick a charity from a drop-down list, and they'll match your donation. We're in that drop-down list. So if you're feeling charitable, I would be very happy. So yeah, thanks everybody for your time.